Hello. Today we're going to start with page 3 of your Chapter 9 notes, and this section is called Angles as Rotations. Prior to today, we've been talking about angles inside triangles, obtuse and acute angles, but what we're going to do now is we're going to be rotating around the origin in the XY plane, and I'll show you what we mean by that in a minute. But first of all, if you have an angle and the measure of the angle is positive, then the rotation around this origin is going to be counterclockwise. If you have a negative rotation, it's going to be a clockwise rotation. So this is just something to keep in mind as we're going to be rotating around. So we're going to talk about a standard position of an angle. The standard position of an angle is when the vertex of this angle is at the origin. So here's this origin. It's always, a lot of times it's marked with an O for origin. So the vertex is at the origin, and it has something called an initial side and a terminal side that's marked here. The initial side is always on the x-axis, on the positive side of the x-axis. So we can mark this here maybe in a color. If you have a colored pencil, maybe you can mark it in red. So this is the initial side. And when we're rotating around the origin, what we do is we rotate in either a counterclockwise or clockwise direction, but we're going to rotate right now in a counterclockwise direction, which is this side. And this angle is going to stop right here. And this is called the terminal side of the angle. So we have an obtuse angle. It's something greater than 90 degrees. But something less than 180 degrees. We've started here and we've gone around here. And I just want to show you one of these things that shows you how you can rotate around the origin. So let's see. I'm going to zoom out here. All right, here we go. So the origin is right here. And this is upside down. And here's the initial side. This is the x-axis, the positive and the negative side of the x-axis, and this is the y-axis. So this blue line marks the initial side. And then when you rotate around, you can rotate around either in a counterclockwise direction like this, or a clockwise direction, which is a negative angle. So if you have an angle between 0 and 90 degrees, it ends up in this quadrant right here. This is called quadrant 1. So we can end up here, like we can have our terminal side be here. That might be an 80-degree angle. Then you can rotate around a little bit more and go into quadrant 2, an angle between 90 and 180. And then you can keep on going, and you can have this big angle rotated around in quadrant 3, which is something bigger than 180 but less than 270. And then you can keep on going and go into quadrant 4, which is something bigger than 270 but less than 360. And you can spin around as many times as you want. You can have an angle that's bigger than 360. If you rotate around twice, you'd go 720 degrees. Or you could go negative. Right, here's a negative angle. If you start here and go around here, this would be like a negative, maybe 40-degree angle. Here's a negative 90-degree angle. This is a negative, something bigger than negative 90, between negative 90 and negative 180. And you can go up here if you rotate around here between negative 180, negative 270, or you can rotate in a clockwise direction all the way back down to quadrant 1 and go negative 360 degrees. So here's this, like I said, this is the terminal side of the angle. You can rotate positive angles or you can rotate negative angles, but this is always the initial side, this x-axis right here. So let's continue with our notes here. Let's zoom in a little bit so we can see. What we're going to do is we're going to draw a few angles here that I've listed. First of all, we're going to be drawing an angle of 30 degrees. So with the initial side always here on the x-axis, 30 degrees is something into quadrant 1, but not too far. So we're going to put a little arrow here, and we're going to mark this as 30 degrees. Always starting on the x-axis. 170 degrees is something a little bit less than quadrant than 180 degrees, a little tiny bit less, maybe over here, always starting at the x-axis, and we're going in a counterclockwise direction. So there's a 170 degree angle. Down here, 190 degrees is something a little more than 180, but remember, we always start over here on the x-axis, and 180 would be here, so 190 would be just a little bit into quadrant 3. So here's a 190 degree angle. You can either mark the angles inside or outside. Now 380 degrees, well, we know 360 degrees is a complete rotation around, so 380 would be 20 degrees more. So what we're going to do is we're going to rotate around like this, kind of look like a snail, and then that's 360, and now we just have to go 20 more degrees. Okay, so here's our initial side always, but our terminal side is here, and look at always mark this with an angle. It tells the direction that you're rotating. Oops, hopefully you saw the other ones. Now negative 100 degrees, negative is clockwise. So negative 90 would be down here, but we need to go negative 100, so it's a little bit further. Always starting here on the x-axis, and we're going clockwise this time, negative 100 degrees. So there are 6 angles that you're going to be drawing or practice drawing. Here's a vocabulary word. Any angle in standard position, remember these are all standard position angles, whose terminal side, remember these red lines are the terminal side, coincides with, which means is the same. It's the same thing as the terminal side, or coincides with the terminal side of another angle, is called a coterminal angle. Okay, what we have here in this diagram right here is we have, and this is a little typo, this is 140 degrees. Take that box and put a little degrees here. I don't know what happened. 140 degrees and 500 degrees. We're going to show why these are coterminal. They share the same terminal side. This right here is the terminal side, remember. This is the initial side. So if we have 140 degrees, we could start here, and we could go around just a little bit beyond 90 degrees, 140 degrees. Or if we wanted to, we could start here again, but we're going to rotate around 360 degrees plus another 140 degrees. So we end up at the same place. But once you spun an entire time around and the other one you haven't. So if you wanted to find a coterminal angle with a given angle like 140, to find the measure of a coterminal angle, you are going to add or subtract 360 degrees from the original angle. Add or subtract. So what we have is we have given 140, so 140 degrees. If we added 360 degrees to that, which is a complete cycle around, you have added up to 500 degrees, and that's a coterminal angle. Whoops. 140 plus 360, 500 degrees. That's how they become coterminal. There's another vocabulary word down here. This is called quadrantal angle. An angle in standard position whose terminal side lies on either the x-axis or the y-axis is called quadrantal. Well, I've shown you 4 major quadrantal angles here. This is 90 degrees. Please put an arrow at the end of this. So 90 degrees ends up on the y-axis. 180 degrees, put an arrow here, ends up on the other side of the x-axis. 270 degrees, put an arrow here, that ends up down here on the y-axis. And then negative 90, here's an example of going in a clockwise direction. So quadrantal angles always have their terminal side either on the x or on the y-axis, and they're always multiples of 90. Now what we're going to do is on our own, or I'm going to show you how to do these. This is what we're going to do in class tomorrow. We're going to draw an angle with a given measure. So we have 6 angles here. I've given you a measure. We're going to draw them in standard position. We're going to tell what quadrant the terminal side is in. in the A blank, and then we're going to state the degree measure of a coterminal angle. So we're going to figure out a coterminal angle to every given angle. So now we have a 60-degree angle. I'm going to put CCW. That stands for counterclockwise because it's positive. 60 degrees is not quite 90, about 2/3 of the way. So what we have is we've got a counterclockwise rotation always starting on this x-axis over here. And let's mark this as 60 degrees. So what quadrant is this in? Let's mark the quadrants. It's like the letters. If you were to draw the letter C, what quadrant would you start in? 1, and then you'd go over here to 2, and then you've got quadrant 3 and quadrant 4. So it's like the letter C, the order of the quadrants. So this is a quadrant 1. And then the coterminal angle. Well, a coterminal angle, all you have to do is take the given angle, 60 degrees, and you can either add or subtract 360. It doesn't really matter. Let's subtract 360. What the heck? Doesn't really matter. So 60 degrees minus 360, if you want to take your calculator out to help you, 60 minus 360, that would be negative 300 degrees. So we have a negative 300 degrees, which would be coterminal to 60. And negative, remember, that is a clockwise rotation. So we start at the same place. We're coming around in this direction. Coterminal is negative 300 degrees. We'll mark that. The next one given is 120. 120, well, it's a little bit more than 90, but not quite over to 180. So it's somewhere in this next quadrant here. So here we go. Here's 120 degrees. In what quadrant? 1. This is quadrant 2. And then we have to figure out a coterminal angle. So we have 120 given to us. Let's subtract out 360 again to see what our coterminal angle is. 120 minus 360 would be negative 240 degrees. So if we start here and go in a clockwise direction, that will give us negative 240 degrees. Coterminal to positive 120. Now we've got 315 degrees. Well, let's see. We've got 90 degrees. We've got 180 degrees. We've got 270 degrees. And then 315 is not quite to 360. It's about halfway in. So here's our 315 degree angle. Quadrants 1, 2, 3. Oh, this one ends up in quadrant 4. So here's a quadrant 4 angle. And if you want to take 315 degrees and subtract out 360 degrees, let's see what we get. 315 minus 360, negative 45 degrees. So negative 45 degrees would be our coterminal angle to positive 315. So negative 45 degrees. Next, we have given to us a negative angle, a negative 225. So now we've got to go in a clockwise direction. So we're going 90 degrees, 180 degrees. We don't go all the way up to 270 degrees. So we go part way in this way. This is a negative 225 degrees. And of course, quadrants 1, 2, 3, and 4, this one ends up in quadrant 2. And if we want to take negative 225 that's given to us, remember you can either add or subtract 360. Let's add 360 this time to negative 225. Negative 225 is given to us. Let's add 360 to get our coterminal angle. Well, we've got 135 degrees. That's positive. So we're going in a counterclockwise direction. 135 degrees would be coterminal to 225 because they share that same terminal side. Now I haven't given you any x and y axes here, but I think we can probably draw our own. Let's see. I get a little xy axis going here. Now what you might have noticed about negative 400, it's bigger than 360. And because it's negative, I guess I'll draw it in red because we're going in a clockwise direction. So we're going to start here. We're going to rotate clockwise around. And remember, all the way around once is 360 degrees. But we have to go another 40 degrees because we got to go all the way up to 400. So 40 degrees isn't quite 90, so we're going up to here. So here's our terminal side. Here, this little angle would be 40 degrees. We've spun around a negative 400 degrees. And what quadrant is that? 1, 2, 3. This ends up in quadrant 4. And now let's take negative 400 degrees and get a coterminal angle. Well, there are many different coterminal angles. You can add 360 degrees to that. Let's take negative 400 and add 360. You have negative 40 degrees. Oops. Negative 40 degrees if you wanted to go in a negative direction here. But I think I want to have a positive angle this time. So I'm going to just add another 360 to it. And I'm going to get positive 320. So negative 400 plus 360 is negative 40. So you could say negative 40 degrees, or you could add another 360 to that and get positive 320 degrees, which is what I want to have. Doesn't really matter. Just mix it up a little bit. So positive 320 degrees goes in a counterclockwise direction all the way around here. Quadrant 4. Remember, this is counterclockwise spin. Now 700 degrees. Well, hopefully you know that twice around is 720. So this is not going quite twice around. But almost. We're going to be just 20 degrees shy of going 2 full rotations around. Oh, that's terrible XY axis. Anyways, so 700 degrees. Always start here on your initial side. So we're going to spin all the way around once. Remember, this is a counterclockwise spin. So spin around once is 360, plus 90 is 450, plus another 9 is 540, plus another 9 is 360, or 630, I mean, 630, and then not quite to 720, just 20 degrees shy. 20 degrees shy would be our 700 degree angle. I think I'll mark it here. So we've got almost 2 full spins. Well, what quadrant does this end up in? Well, this ends up in quadrant 4, all the way around here. So quadrant 4. And now let's take our 700 degree angle. Let's subtract out 360 once. Oh, and we get a positive 340. Let's subtract out another 360. What the heck? We'll do a negative 20 degrees just to get a negative angle here. So negative 20 degrees, remember that's a clockwise. Negative 20, that's clockwise. So what we did, again, we took 700 degrees, we subtracted out 360, and we got 340. That is a coterminal angle. Whoops. 340 is a coterminal angle. You could have used that. It doesn't matter. But I just happen to say, let's subtract out another 360, and you get a negative 20 degrees. So I just gave you a positive and a negative one. So that's how you draw the angles. And now simply finding 3 angles that are coterminal with the following angles. Well, all you have to do, remember, is you just add or subtract. It doesn't matter whether you add or you subtract 360 degrees to the given angle. Doesn't matter. So we'll take our 470. So let's see, what can we do? Let's subtract out 360. We got 110 degrees. That's one coterminal angle, 110 degrees. Let's subtract out another 360. Negative 250. And let's subtract out another. Oh no, you know what? Let's take the original 470. Let's add 360. Let's get 830 degrees. So there are 3 coterminal angles if we wanted to draw them. It looks like they would all end up in quadrant 2. 110 degrees would be here. 470 degrees would be a complete spin around and end up in quadrant 2. Negative 250 would be coming back this way, and positive 830 would be 2 spins around and then another little bit. But all of these angles end up in quadrant 2. I'll just put Q2 here for quadrant 2. All of them. They're all the same. 755. All right, let's take 755. Let's subtract 360, and we get 395. Do you see how easy it is to find coterminal angles? Let's subtract out another 360. We get 35 degrees. Let's subtract out another 360, and we get negative 35 degrees, or 325 degrees. I'm sorry, I misspoke. So if you wanted to draw that, well, 35 degrees just ends up here in quadrant 1. 395 would be a complete spin around. Negative 325 would be a clockwise rotation, but all of them end up in quadrant 1. And then the last one, negative 50 degrees. Let's add 360. We get 310. Positive. Let's add another 360 to that. 670. And let's take our negative 50 that we were given and let's subtract out 360. And we get negative 410. So those are 3 coterminal angles. And what if we wanted to graph them or draw them? 310 degrees would end up down in quadrant 4. 670 degrees would be a complete spin around and then this way. Negative 50 would just be this little bit right here. And negative 410 would be a complete clockwise spin around and then a little bit more. So these all end up in quadrant 4. And we use Roman numerals for our quadrants. And that's it for today. Hopefully you saw everything that I drew and I didn't go off the camera at all. Have a good night, and we'll practice this tomorrow.